Okay, so we would like to talk about limits. So this is an introductory lesson on limits. So let's see what limits are, why limits are important. Let's talk about that for a minute before we visualizing it. Well, limits are important in calculus and mathematical analysis, and is really used to define integrals, derivatives, and continuity. It is used in analysis process and always concerns about behavior of the function at particular point. We will see that. So let's get it started. So I would like to draw a curve, and let's start by doing that. So I'm just gonna, by the way, that's our x. We get my pen right. Okay, so we have, my pen is not working. Okay, so we're gonna draw a curve that is not continuous at particular point. And what we are going to do is, this is the point of discontinuity, and we're just going to name it A. And then we're going to pick a point on the left side of it. Just call it X, since it's on the x-axis. And then we pick a point on the right side of it, and we're also going to call it X. So let's take a look at this. Let's label this. This is X, and that's Y equal f of X. If this is X on my x-axis, this point is going to be called f of X. And then I have X right here on the right side of A. That's also f of X. And A is any number on the x-axis, so we're gonna get a Y value for here, and that's going to be L. L is any number. So what limit is saying is that f of x, our f of x, let me get a different color right now so you can see it more, so we can visualize it. It says f of x will approach L if x approaches A from left side and right side. Okay, so f of x will approach to L when we go to A from left and right. So what's really important about this one? So let's write down what we just said a minute ago. Limit of as x approaches A of f of x is equal to L. So we will approach L when we get very, very close to A from left side and right side. Notice that note that our f of A is undefined. So that's undefined. But limit says I do exist. I do not care about the value of f of A. I do not care about this continuity as long as f of x behaves. So it's the behavior of the f of x that the limit cares about. A limit is saying that as long as when you get very, very close to A, from right side and left side, your f of x will get close to L. And that is going to be the limit of the function. So it's the behavior of the f of x that is really important, not f of a itself. That's the whole point about the limit. So as we go from the left and we go from the left and the right, if you go there, get very close, and if the limit exists, the y values will basically get very, very close to L, and then says L is saying that number. So let's jump on and do one problem with this, so you could see it with rather than when the letters, we could see a concrete example. Let me make up an example for you, and let's say we have limit of my pen. Okay, so let's say we have limit of x approaches 0 of x squared plus 2x divided by x. Okay, notice that by direct substitution, when x is equal to 0, note, let me write it down. Note, when x is equal to 0, when x is equal to 0, we get 0 squared plus 2 times 0 divided by 0 will give us 0 divided by 0, which is meaningless or undefined. However, observe that the limit of x approaching 0 of x squared plus 2x when we factor it. So if we factor it, this will give us limit of x approaching 0. We get x plus 2 divided by x is simply limit of x approaching 0 of the x's cancels x plus 2, which is really equal to 2. So the limit is saying, despite that x cannot be 0, I do exist. And it's further saying that I am really the same thing as this, x plus 2. Okay, so you could think it as different function, one f of x and one is g of x. You say, I'm exactly the same thing, except at the point x equal to 0. So if you want to graph this function, instead you could do exactly this function right here. Except notice that limit is saying that the function is not defined at x equals 0. Okay, so note, please note, important note, that f of 0 is undefined. But algebraically, we showed that the limit exists. But let's look at it by visualizing, just like we did with slide 1. So let me just graph this function. Let's draw x-axis and y-axis. Actually, I'm going to go to the next slide and I will have x-axis and y-axis ready for you. Let's go here. And we want to graph it, okay? So to graph it, we have x-axis and y-axis ready. So that's our x-axis and that's our y-axis. And this function that we're going to graph is going to be y equal x plus 2. So just go here. We got to make sure we put a hole here, because when x is equal to 0, the function is undefined. So we just go here too, and then we graph this function simply. As simple as that. Okay, now, this is the point I want you to pay attention, and once you got it, you got the calculus, okay? I just want to make sure that you observe the moment. Now, we are approaching 0, okay? We are approaching 0 from the right side, and the left side. So that's really important, from the right side and the left side. So we're going this way. The limit is saying, watch how f of x is behaving as you get close to this point. So that's this little guy at 0. Pay attention to that. Pay attention to that. So let's do that. Let's say we start at 1. And what's really happening here is that, and our graph is really y equal x plus 2. So it says that when you're at 1, you're going to be right there. So look at the behavior of this f of x, where it's going. Watch this guy out. And I'm getting closer to my 0 right here. I'm getting closer here. I would like to get closer here. So I'm just going to move to the left. Okay. So notice that this guy is moving down as I go. And okay, he's going in the right direction. So hopefully, and we're going to do more. So you can see that he's going down. He's right here. So as you keep on going, and you will see that you get very close. See that every time on the y-axis, look at here. You are really going down to a number. So you keep on doing this. And what is this number? This is a 1 and that's a 2. You're getting very close to the 2. And it's saying, you know what? Do the same thing with the left side. From the left side. So you say, okay, I'll do the same thing with the left side. What's really happening here? So I'm starting from maybe from this point, and I'm just going to go, I'm going to be right here and keep on going the more closer. Now I'm going to go a little closer from left side to the 0, and I'm going to be right at this point, and this guy is right here. Look what's happening. Look at where he's going on the y-axis. He's getting closer and closer. Is getting closer and closer to 2 from the left side too. So this number limit is saying, this is the beauty of limit. I hope that you observed it here. It's getting very, very close to 2. Very close to 2 as to the closest that you could get. And that's why the limit is saying, hey, despite the fact that f of this number, 0, is undefined, I do exist. And my limit of x approaching 0 of my f of x is exactly f of x is really 2. And ladies and gentlemen, that's the whole concept. That's the whole concept of the limit. I hope you observe it. I just want to emphasize the fact that the limit depends only on behavior of f of x near x equal a, near 0. You see that our f of x extremely behaved well. It got closer and closer to the same value. If they go the different direction, then forget about it. So limit is saying, I'm going to watch f of x, how it's behaving. If from both sides it approaches the same value, then I do exist, despite the fact that f of a does not exist. Whether it exists or not exists is not important. Okay, f of a is not important by itself. It's the values close to a, x equal a, that we have to watch the behavior of f of x. I think this is really a great presentation, and you be the judge. And if you like it, like the video and watch it maybe once, twice, 3 times, because if you got it, you got the calculus. Have a great day. Thanks for watching.